Okay, today we're going to look at polygons and their angles. These are the notes that you have in class, so we're going to fill them in as we go today. Simple polygons have sides made of segments. They're only segments. The sides are always straight sides and never curved. So if you see a curved line in your figure, it is not a polygon. Their endpoints connect at a vertice. That's the point where two sides come together. And a vertex can only connect two sides. So that endpoint, that vertex can only connect two sides. Segments that connect opposite vertices are called diagonals. And we had those in our polygon properties. If one side is extended, an exterior angle is created between that side and the adjacent side. Okay, so what are polygons? What are they really? Well, they are made out of the straight sides, like our triangles, our quadrilaterals. Can kind of look like this little rocket ship. My star. Don't laugh at my star. Okay, as long as they're made up of all straight sides and they connect at the vertices. What are not polygons? Okay, they can't crisscross each other. Okay, I can't have one straight side and then a curved side. I can't have an incomplete one. Okay, all of the vertices need to touch each other. And again, it's got to be made all of straight sides. So this part right here is curved. Wouldn't make it. Convex. We have convex and concave. Okay, convex means all vertices are outside. Which means there's no dents in our figure. No dents. So examples of would be like a right triangle here that doesn't have any dents. This pentagon doesn't have any dents. This quadrilateral doesn't have any dents. Okay, so concave mean it does have dents. And kind of the word is cave, like it caves in. So my star, that would be concave, because if I look at these 2 points here, they cave in. They go inside. If I take a look at this figure here, and look at the points from here to here, that caves in. And if I have this figure here and I look from here to here, that part caves in and goes inside. Equilateral is all sides are congruent. We're familiar with this term. All sides are congruent. We'll add all sides are congruent. Your sides, those are congruent. These markings indicate congruency, that they are all the same length. And we have our rhombus. That would also be considered congruent. Equiangular means all angles are congruent. All the angles are congruent. That could be like our rectangle, which we know has 4 right angles. And then we can have this hexagon shape. And all of these angles would be congruent. Now, regular means that the sides and angles are congruent. Okay, so that would be like our equilateral triangle, where all the angles are congruent and all of the sides are congruent. That would be like our square, where all four sides are congruent and all four angles are congruent. And then we can have our hexagon, which would be like a honeycomb shape, where all six sides are congruent and all six angles are congruent. Okay. Now we're going to get into our shapes and identifying them and figuring out the different angle measures. So our first shape here, we have a triangle. So I'm going to label that my triangle. I do know it has three sides, and we know our interior angle sum. We know that all three angles in a triangle add up to 180 degrees. If it's regular, then I know that each interior angle is going to be 60 degrees because 180 divided by 3 gives me 60. And I know my exterior angle, it forms a linear pair with the interior, so I can take 180 and subtract 60, and I can get the interior angle, which is 120. Another way to find it is that all the exterior angles will add up to 360, and since I have three angles on the outside, 360 divided by 3 also equals 120. Okay, our next shape is a quadrilateral. That's the general form. We know it has four sides, and we had our quadrilateral sum theorem that told us that the interior angles add up to 360, and we talked about that I can draw a diagonal across, and that gives me two triangles, and since each triangle is 180 degrees, that adds up to 360. I can get each interior angle by taking that sum and dividing it by 4, and I get 90. So each interior angle is going to be 90. And because the sum of the exterior angles adds up to 360 and I have four angles, that also equals 90. And they do add up to 180 because they do form a linear pair. Okay, we've got a pentagon. This one has 5 sides. Now if I start at one of these vertices and I draw the diagonals in, I get 3 triangles. Well, 3 triangles at 180 degrees each comes out to 540 degrees. So the sum of the interior angles of a pentagon is 540 degrees. I can find each one, if it's regular, by dividing 540 by 5, and I get 108 degrees. And then I can get the exterior, because I know all the exterior angles add up to 360, and I can divide that by 5. And I get 72 degrees. Okay, here we have a hexagon. That's 6-sided figure. Okay, if I were to connect the vertices, I would create 4 different triangles. So that's 4 triangles at 180 degrees. And that's going to equal 720 degrees total. So a hexagon has 720 degrees. That's 720 degrees divided among 6 angles gives me 120 degrees for each one. And then I know the sum of the exteriors 360 divided among 6 angles, and that gives me 60 degrees. And I know I'm on the right track because 120 and 60 adds up to 180. Okay, so we'll continue. Okay, so my next shape is called a heptagon. Heptagon is 7 sides. And just as before, if I make my triangles, I will have 5 triangles. 5 triangles times 180, that's going to give me 900 degrees. 900 degrees divided among 7 angles, that does give me a decimal, gives me 128.6 degrees. And 360 divided by 7 is going to give me a decimal too, 51.4 degrees, but they still add up to 180. Our octagon gives us 8 sides. I can create 1, 2, 3, 4, oops, I missed one. 1, 2, 3, 4, 5, 6 triangles. 180 times 6 gives me 1080 degrees. So all these angles inside the octagon add up to 1080 degrees. And I'm going to divide that by 8. And I get 135 degrees for each one if it's regular. And then 360 divided by 8 gives me 45 degrees. And again, I can see they add up to 180. 9-sided figure is called a nonagon. 9 sides. And again, I can create 1, 2, 3, 4, 5, 6, 7 triangles. So 7 triangles at 180 degrees each is 1,260 degrees. So all these angles are going to add up to 1,260. When I divide it by 9, I get each one would be 140 degrees, making each exterior angle 40 degrees, because 360 divided by 9 is 40. And our last shape here is called a decagon, deca being the prefix for 10. So we have a 10-sided figure. And I can create 1, 2, 3, 4, 5, 6, 7, 8 triangles. And that's going to give me 1,440 degrees. Divided by 10, that makes each individual angle, if it's regular, 144 degrees. And 360 divided by 10 gives me 36 degrees for each exterior angle. Okay, so we're going to fill in our table. And we're going to have a 3-sided figure we've called our triangle, so we're going to fill this in with triangle. The sum of the interior we had was 180 degrees. Each interior was 60 degrees, and you can look back up at your picture. And each exterior was 120 degrees. We had our quadrilateral. The sum was 360 degrees. We divided that by 4. We got 90, and 360 divided by 4 again gave us 90 for each exterior. Our 5-sided was a pentagon. We got 540 degrees. Each interior was 108 degrees, and each exterior was 72 degrees. We have our hexagon. Our sum was 720 degrees. Each one was 120 degrees on the inside and 60 degrees on the outside. And if you'll notice, our sum keeps going up by 180 degrees each time. Because we're adding a side, we're adding another triangle, which means we're adding another 180 degrees. So our heptagon, our sum was 900, and we can see our picture here. It was 128.6 degrees and 51.4 degrees. And we have our octagon, and it was 1,080 degrees, 135 for the interior and 45 for the exterior. Okay, now our name when we have our variable here, we just call it an n-gon, so the number of sides gon. Our sides were n, and we've noticed that we have n minus 2. That's the number of triangles that's created. So to get our formula, because that represents the number of triangles, we have n minus 2 times 180. To get each one, we take that sum, 180 times n minus 2, and we divide it by the number of sides. And then we have each exterior one, which is 360 degrees, and we divided it by the number of sides as well. So here is our polygons and the sums of the angles and the patterns associated with